This video is going to go into empirical and molecular formulas. First off, we're going to start with what we already did, and we simply make things in the smallest whole number ratio. That's the empirical formula. So we're simply going to take H2O2. Each of those can be divided by 2, and we're going to end up with HO. CH4, nothing can be made smaller, so this one's going to stay CH4. We're going to end up with CH2. And lastly, oxygen. Okay, so now what we're going to do is we're actually going to go into calculating these values. Okay, calculating empirical formulas. So what I've got here, I'm not going to go through this. It's the steps to go ahead and do these. I just want to go ahead and run through an example problem right here. Okay, so the very first thing that we have to do is we're simply going to take the percentages and turn them into grams, and all that involves is just rewriting the number but making it grams instead. And then we're going to turn that grams into moles, and we are working with sodium. Sodium is 22.99 grams per 1 mole. Go ahead and calculate that. We got to worry about our sig figs, and each of those have 4. So I'm going to end up with 1.048 moles. Then we're going to do the exact same thing. Get rid of that line. But now we're going to do it with the sulfur, and sulfur is 22.65 grams. And again, that comes from the percentage, just changing a G instead of the percentages. Okay. Sulfur is 32.07 grams going to 1 mole, and that's going to give us 0.7063 moles. And then do the last one, which is the 44.99 grams of that, and that's of oxygen, so 16.00 grams going to 1 mole. Do the math, 2.812 moles. And then what I'm going to do is I'm going to take a look at these 3 numbers, okay? Whichever one is the smallest, that's the one that you're going to divide all 3 of them by. So the smallest one happens to be the middle one, so 0.7063. Do that same number, 0.7063, on the other 2. And then what we want to have is nice whole numbers, okay? So I'm not going to do like 2.00, okay? I'm just going to make a nice whole number. When we do that one, we're going to get a whole number of 2, then we're going to get a whole number of 1, and then we're going to get a whole number of 4. And those correspond to the elements. So we have 2 sodiums, 1 sulfur, and 4 oxygens. So when I actually write my empirical formula, we're going to have Na2SO4, and that is your final answer. Let's do another one. One that is got, we have to multiply our ratio that we get in the end. Okay, start off same thing, 43.7 grams. And I am dealing with I'm dealing with phosphor from the periodic table, 30.97 grams to 1 mole. I go ahead and get that, 1.41 moles. And then 56.3 grams for the oxygen, 16.00 grams to the 1 mole. And we're going to get 3.52 moles. Again, divide by the smallest number, so that's the 1.41. 1.41, okay? Whole numbers, we're going to get a 1. But now when we get this one, it ends up to be 2.5. Now that's too far to round up. So what we're going to do here is we're going to multiply everything by 2, because I have to do them, all of them. Okay? If you multiply by a number, you got to do the same to the other. So our empirical formula then is going to be P2O5. Next one. Molecular formulas. Molecular formulas are what actually happens in nature, okay? Because, for example, sugar Okay, when plants do their photosynthesis, the sugar that they produce is C6H12O6. That's the molecular, because that's what we see in nature, but we could easily divide all three of those by 6, okay? So again, the molecular is what we see in nature. The empirical is when it's divided by its smallest whole number ratio, okay? We're just going to go ahead and do the examples. This is the steps that you need to have in order to do that. And note here, the very first step is to have the empirical formula. So if you're not given the empirical formula, you have to go back and do everything that we have just done. Okay. All right, the example. Determine the molecular formula of a compound with the empirical formula of CH. First thing, take your empirical formula, okay, and add up all of those masses. 13.02 grams per mole. Okay. Then we're going to take the formula mass that is given to us, the 78.11 grams, and I'm going to divide it by my empirical formula mass, the 13.02 grams. You want to get a nice whole number for that. That whole number is going to be 6. So here's what you do. Take your empirical formula, the CH, and multiply all of those elements by 6. So we're going to get C6H6, and that is your molecular formula. Next one is actually doing where we need to do the empirical formula first, because it's not given here, okay? So we're going to start off just like we did before, okay, and take the percentages and turn those to grams. So we're going to get 24.3 grams of carbon. Carbon is 12.01 grams, going to 1 mole. 2.02 moles. Next one is the hydrogen, 4.1 grams, going to, hydrogen is 1.01 grams, going to 1 mole, and we're going to get 4.1 moles. And then the other one, the 71.6 grams, that's for chlorine, 35.45 grams, going to 1 mole. And that happens to be 2.02 moles. Find which one of the three of those is the smallest, which is going to be 2.02, and divide all of those values by 2.02. And we're going to get whole numbers of 1, 2, and 1, okay? Which means our empirical formula then is CH2Cl. Okay? That's the empirical. Now going into the molecular, take that empirical formula, add up all of those masses, which happens to be 48.47 grams. And then the information, it gave us a formula mass of 98.96. So that's what I'm going to take here first, 98.96 grams. And we're going to divide it by that molar mass that we just figured out of the CH2Cl, the 48.47 grams. You want to get a nice whole number, and in that case, we are dealing with 2. So what we're doing here is this CH2Cl, okay, this compound right here, we're going to multiply that entire thing by 2. And so our final answer then is going to be C2H4Cl2, and there is the molecular formula, and that takes us to the end of Unit 6.